అవుతుందా? Hello, are you audible, right? Hello. Room open. Ping చేయాలి. వీడియో నాకు 2 times నాకు. కింద అది ఎనేబుల్ చేసి. మళ్ళీ వస్తది. డైరెక్ట్ జాయిన్. మౌస్ కొంచెం స్ట్రీమ్ అవుతుందా? రైట్ నాన్న. రైట్ బోర్డు పైన ఎక్కువ పడుతున్నట్టుంది కదా. ఓకే. Hello. So last class what we were discussing now? Yeah. So we are discussing aromatic compounds, anti-aromatic and non-aromatic, right? So aromatic compounds I discussed. Aromatic compounds are more stable than non-aromatic compounds. Non-aromatic then and anti-aromatic. Anti-aromatic compound should be cyclic, right? They should have the resonance. Compounds are planar and they should obey the 4n plus 2 5 electrons. So these things already yesterday we discussed, right Nana? So now, for example, here is the hydrogen is there. Which of the following, write a question, which of the following is more acidic nature? More acidic nature. Which of the following is more acidic nature? This case A, B, C. A, B, C, which of the following is more acidic nature? Which one, Nana? Hello. Which one? So which is more acidic nature? Acidic nature means also negative charge is coming. Here is also negative charge is coming. Now this is aromatic. After giving the H plus, it becomes aromatic. Aromatic means more stable. So option C, then B, then A. In case of B, we are having the resonance. Because of the resonance, this is somewhat more acidic after C. First C is more acidic because after losing the H plus, what exactly happens, Nana? Aromatic nature is coming. Okay? Hello? No, I'm just speaking about the acidic nature. I'm asking the question. After losing the H place, the compound which is forming is more stable, right? అందుకోసమని అది తొందరగా లూజ్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ నాకు ఒక 10 రూపీస్ ఇస్తే నీకు 1 lakh రూపీస్ ఇస్తానని అనుకో. కండిషన్ నెంబర్ 1. నాకు 10 రూపీస్ ఇస్తే 100 రూపీస్ ఇస్తా అన్నది కండిషన్ నెంబర్ 2. 10 రూపీస్ ఇస్తే 10 రూపీస్ ఇస్తా అన్నది కండిషన్ నెంబర్ 3. ఈ 3 కేసెస్లో నువ్వు ఎప్పుడు తొందరగా ఇస్తావు? ఏ కేసులో? 10 రూపీస్ ఇస్తే 1,00,000 రూపాయలు ఇస్తానన్నావు కదా, ఈజీగా సరే తీసుకోండి అని ఇస్తావు. అందుకోసం అది అంటే H ప్లస్ తొందరగా లూజ్ అయితే వచ్చే కాంపౌండ్ ఏమవుతుంది? మోర్ స్టేబుల్ అవుతుంది కాబట్టి, రైట్? ఈ బోర్డు పైన ఏమైనా రిఫ్లెక్షన్ పడుతుందా మీకు? హలో, క్లియర్నా ఎవ్రీవన్? అండ్ వన్ మోర్ ఇంపార్టెంట్ క్వశ్చన్, దే విల్ ఆస్క్ different types of questions none here. For example, in this case, so they'll ask the question, which this CC bond, that yellow color bonds which I'm showing, which CC bond length is more? The yellow color one. Which CC bond length is more? CC double, both are double bonds. Which CC double bond length is more? Tell me the answer. Akshita Rale. First one. Why first one? No? అలా కాదు. ముకుంద్ అంటే సి డబుల్ బాండ్, యాక్చువల్లీ డబుల్ బాండ్ అండ్ సింగిల్ బాండ్ రా. విచ్ బాండ్ లెంత్ ఈజ్ మోర్? CC single bond length is more, CC double bond length is somewhat less. If CC triple bond is coming, the bond length is keep on decreasing. So particularly in this case, the bond is here, above case, it becomes, for example, it is existing like a single bond. Why? It is negative charge, it is positive charge. What exactly happens? Both are, this is above one is aromatic, below one is aromatic. So means instead of double bond, it wants to stay in the single bond mode. But whereas in this case, one is right, any case, so it is right, for example, negative charge, it is positive charge, but one is aromatic, one is anti-aromatic, right? So for example, ఇద్దరు ఇక్కడ ఏమవుతుంది? సో వీడికి బెనిఫిట్ అవుతుంది అన్నప్పుడు బాండ్ బ్రేక్ చేసుకొని ఇలా ఉండడానికి ఇష్టపడతారు. అప్పుడు ఏంటంటే ఇక్కడ సింగిల్ బాండ్ అనేది ఉంటుంది, రైట్? సో సింగిల్ బాండ్ ఈస్ ప్రజెంట్ హియర్. వేరాజ్ ఇన్ దిస్ కేస్ వాట్ ఎగ్జాక్ట్లీ హ్యాపెన్స్? సో ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఆ బాండ్ బ్రేక్ చేస్తే ఒకటి బెనిఫిట్ అవుతున్నాడు, ఇంకోటి అవ్వట్లా, ఒప్పుకోడు కదా బాండ్ బ్రేక్ చేద్దామంటే. ఫర్ ఎగ్జాంపుల్ ఒక బాండ్ ఉంది, అరే ఈ బాండ్ బ్రేక్ చేస్తే ఇద్దరం బెనిఫిట్ అవుతున్నామని అంటే ఏంటి? ఓకే ఫైన్. బట్ ఒకటే బెనిఫిట్ అవుతున్నాడు, ఇంకోటి బెనిఫిట్ అవ్వట్లేదంటే కాదు కదా. సో ద సేమ్ మ్యానర్ అంటే ఇక్కడ డబుల్ బాండ్ అనేది సింగిల్ బాండ్ లాగా ఎగ్జిస్ట్ అవుతుంది. ఎందుకు? బికాస్ బోత్ ఆర్ ఎరోమాటిక్. అంటే వాళ్ళు ఇంకొక దిస్ సేమ్ క్వశ్చన్ ఇంకోలా కూడా అడుగుతారు. విచ్ ఆఫ్ ద ఫాలోయింగ్ సి రైట్ ఫ్రీ రొటేషన్ ఇస్ పాసిబుల్ అంటాడు ఇన్ దిస్ 2 కేస్. ఆ 2 కేసెస్లో డబుల్ బాండ్లో ఫ్రీ రొటేషన్ ఎక్కడ పాసిబుల్ అవుతున్నారు? ఎందులో పాసిబుల్ అవుతుంది ఫ్రీ రొటేషన్? వేర్ ద ఫ్రీ రొటేషన్ ఇస్ పాసిబుల్? జనరల్ ఫ్రీ రొటేషన్ కార్బన్ ఎప్పుడైనా CC సింగిల్ బాండ్ ఉందనుకుంటారా, ఫ్రీ రొటేషన్ ఈస్ పాసిబుల్. రైట్ ఇట్ డౌన్. CC సింగిల్ బాండ్ ఈస్ present, that free rotation is possible. In case of CC double bond or triple bond cases, restricted rotation, free rotation is not possible. Free rotation is not possible. నా ఫేస్ కొంచెం బ్రైట్గా కనిపిస్తుంది నిన్నటితో కంపేర్ చేస్తే. లైట్ వెయిట్. లైట్ ఆల్రెడీ పాతది ఉంది. మన దగ్గర అన్నీ ఉంటాయి కానీ వాడము కదా. నా దగ్గర అని కదా, అందరి దగ్గర అన్నీ ఉంటాయి. తెలివి ఉంటుంది, టాలెంట్ ఉంటుంది, అన్నీ ఉంటాయి. బట్ మనకేంటంటే వాడడం రాదు. నిన్న వీడియో స్ట్రీమింగ్ చేశాను కదా, సో నిన్న చూశాను నేను. సంథింగ్ లైట్ డిఫరెన్స్ ఉందని చెప్పేసి ఈరోజు పెట్టి వర్క్ అవుతుందా అంటే లైవ్ స్ట్రీమింగ్ కదా, లైవ్ స్ట్రీమింగ్ కాబట్టి అలానే ఉంటుంది. చూద్దాం, అంటే రెక్టిఫై చేసిన ఇప్పుడే కదా మనం పెట్టింది. ఇప్పుడు ఈ కాన్సెప్ట్ అర్థమైందా? సో విచ్ in these two cases where the free rotation is possible అంటాడు. Where the free rotation is possible, right? First case, because it can CC single bond is existing here, but in this case CC single bond not existing. So means in this case carbon carbon free rotation is possible, but not in this case. Then no. They'll ask different types of questions. బాండ్ లెంత్ దీనికి ఎక్కువ ఉంటుంది. ఎందుకు ఉంటుంది అంటే రెండు కూడా సింగిల్ బాండ్లో ఎగ్జిస్ట్ అవ్వడానికి ఇష్టపడతాయి, బికాస్ బోత్ ఆర్ ఎరోమాటిక్. సో ఎరోమాటిక్ ఉండడం వల్ల ఏమవుతుందంటే, రైట్, సింగిల్ బాండ్లో ఎగ్జిస్ట్ అవుతాయి. బట్ ఇక్కడ ఏంటంటే డబుల్ బాండ్ని బ్రేక్ చేయడానికి ఇష్టపడవు ఈ రెండు. ఎందుకంటే ఒకటైతే ఎరోమాటిక్ అయితే ఒకటి నాన్ ఎరోమాటిక్ అవుతుంది, యాంటీ ఎరోమాటిక్ అవుతుంది. ఒకటి ఎరోమాటిక్ అయితే ఇంకోటి యాంటీ ఎరోమాటిక్, అంటే ఒకటి స్టేబుల్ అవుతుంది ఇంకోటి అన్స్టేబుల్ అవుతుంది. సో దే ఆర్ నాట్ అగ్రీయింగ్. సో ఇక్కడ డబుల్ బాండ్ లాగానే ఉంటుంది, సింగిల్ బాండ్ ఉండదు. సో ఎప్పుడైతే సింగిల్ బాండ్ ఉంటుందో బాండ్ లెంత్ ఎక్కువ ఉంటుంది, ఫ్రీ రొటేషన్ ఈజ్ ఆల్సో పాసిబుల్, రైట్? సో వెనెవర్ ద both are aromatic, that cases the bond is existing as a what? Single bond, right? Single bond and free rotation is possible. So yesterday I told you why benzene does not undergo addition reactions. Why benzene does not undergo addition reaction? It losing its stability, aromatic nature అనేది పోతుంది, right? Hello, any doubts from yesterday's? Hello, questions, anyone? Is this compound aromatic or not? No? Obviously aromatic. So even though these are the resonating structures are possible, even this is also aromatic compound. Done? And today I'll discuss something about hyperconjugation. Then we'll see the applications of combination of all these three, right? Put the heading hyperconjugation. How many of you know hyperconjugation? Hyperconjugation. How many of you know hyperconjugation? Hyperconjugation is one of the important. We could say this is no bond resonance. No bond resonance. No bond resonance. So means, for example, try to understand. This is which carbocation? 3 degree, right? 2 degree, 1 degree carbocation. Which is more stable, Nana? Which 3 degree, 2 degree, 1 degree? Which is more stable? 3 degree. So how we are telling? Because according to inductive effect, we explain because plus 3 plus I groups are there, right? It is 3 plus I groups are donating. So 3 plus I groups are donating. In this case, 2 plus I groups are donating, right? It is 1 plus I group is donating. Yes or no? But here, this is the same concept we can explain in terms of hyperconjugation, right? So for example, if I am taking the methyl, this one now, hydrogen, 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 pH 2 plus, pH 2 plus, right? So now in this case, the bond between the hydrogen and carbon is coming like this, right? So what exactly happens? H, P, H plus, H, right? CH2, the double bond is coming here. And once again, this bond coming back, coming and going like this. Hello. So bond is, in this particular case, what exactly happened? No bond between, Chepnana. So in this case, there is no bond between carbon and hydrogen, right? No bond between carbon and no bond resonance. So means immediately this is come back. This is front and back. The reaction is keep on takes place, right? The bond is there between hydrogen. It's coming like this and right coming back. So no bond. Particularly when it goes like this, no bond. Like how many hydrogens are there? 3 or hydrogens are doing the same mode. So we can write one more hydrogen also. అర్థమైందా ప్రణయ్? So how many hydrogens are there? That many H plus double bond CH2. Okay. Hello. So how many hyperconjugation structures we are getting? 3. 3 alpha hydrogens, right? There is 3 alpha hydrogens are there. 3 hyperconjugation structures we will get. But whereas in case of secondary case, right? How many alpha hydrogens are here? This is alpha. Total 6. 6 alpha hydrogens are there. Means 6 hyperconjugation structures we will get. In this case, Nana, 9. So write one more point. More hyperconjugation structures, compound is more stable. 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 So now in this case 3 degrees more stable than 2 degree than 1 degree, right? Right hand. Dana? Completed, right? Pranay, చెప్పు. Then ra. So now let me know of the following. Write the stability order of carbocation. Right now. So A, B, C. Right? Which carbocation is more stable? Which carbocation is more? First, try second one. Okay. Mukund, third one. Charit, third one, right? Pranay? Hmm? What alpha carbon? This is alpha carbon, this is alpha carbon. And this alpha carbon is already having the two bonds. Means how many hydrogens it is having? Two hydrogens. It's already having three. So whereas in this case, this is alpha, this is alpha. Here is two hydrogens. Carbon is always having four bonds, right? Here is one hydrogen. How many total? 5 alpha hydrogen. But whereas in this case, this is alpha, this is alpha, this is alpha. In this case, 3 hydrogens now. Here is also 3 hydrogens. Here is one more. Total 6 plus 1, 7 alpha hydrogen. Now let me know which is more stable. T, then B, then A. Anybody having any doubt? Anybody having any doubt? So if you are unable to draw that, write the carbon structure like that. Okay, CC carbons like C, E. So based on that, you can understand. So two bonds are there. Means CH2 will write CH2, 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 CH like that. Okay. So a lot of people are confusing this small tree. So if you are confusing in this way, write like this. Done. So which carbocation is more stable? And let me know alpha hydrogens, A and B. B is having how many alpha hydrogens? Right? It is 3, 3, 2, 8. Here is 1, 3, 4. A and B. So let me know which is more stable. Both are tertiary, right? Sometimes we are confusing according to the inductive effect, but in this case, A. Akshita. Isha. Why? How many alpha hydrogens are with A? 7. B. 5. Calculate clearly. Any other answers? Online guys? Mukund? It is 2. It is 2. In this case, 3. Total how many? 7. Here, it is 2. It is 2. It is 2. 6 alpha hydrogen. Which is more stable? A. Okay. Same mode, we can go with the carbon free radical also same. Carbon free radical also, we can do the same thing. In case of alkenes also, this is one of the important, Nana. So alkenes also we can explain. For example, CH2 double bond CH2, option A. Tell me which of the following alkene is more stable. Write the compound. Which of the following alkene is more stable? Which of the following alkene is more stable? So here is also we need to identify the alpha carbon. Alpha carbon means double bond adjacent carbon, generally we are called as alpha carbon, right? Here is, this is the alpha carbon, alpha, here is alpha, this is alpha, alpha, alpha. Alpha carbon means what? Double bond adjacent carbon, right? Now let me know. So the first one is having how many alpha hydrogens? 0. In this case, 3. Here is 6. Here in this case, 9. In this case, 12. Right? Which is more stable? Right? More alpha hydrogens. So how can we write? Here is also same mode. We can write the hyperconjugation structures. For example, the first one which I am taking like this. Right. So in this case, bond is coming here, so automatically this bond is migrating to. So I'm just writing the one structure, CH plus H H CH double bond CH H2 negative charge. Okay, like this. Like 3 hydrogens are participating, so we'll get 3 structures, 3 hyperconjugation structures in this case, right? 6, 9, 12. I told you more hyperconjugation structures compound is more stable. ఇలా కొడుతున్నా దీని మీద పడుతుంది. Okay. సోనా వింటున్నావాను? సోనా సోనా hello, right Anna. Write the question one more. Which of the following alkene is more stable? Right Anna. కొంచెం which of the following alkene is more stable? Which of the following alkene is more stable? Which of the following alkene is more stable? Tina. Right Anna. What is the answer? Case of option A, how many alpha? Alpha, 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 right? 2, is 2, 2, 1, right? Hello. How many nana total? 5. Here 3, 3, 2, 2. Total 10. It is 3, 1, 4, 2, 1, 3. Right? So what is the order? P, A, C, D. B, A, C, D. Done? ప్రణయ్ అర్థమైందా? నెక్స్ట్ ఇక్కడ హీట్ ఆఫ్ హైడ్రోజనేషన్ అని ఒక కాన్సెప్ట్ వస్తుంది, రైట్? విచ్ ఆఫ్ ద ఫాలోయింగ్, రైట్ ద క్వశ్చన్ వన్ మోర్, సేమ్ ఆప్షన్స్, రైట్? విచ్ ఆఫ్ ద ఫాలోయింగ్ ఆల్కిన్ ఈస్ మోర్ హీట్ ఆఫ్ హైడ్రోజనేషన్? మోర్ టేబుల్ కాదు ఇక్కడ, మోర్ heat of hydrogenation. So the following, more heat of hydrogenation. More heat of hydrogenation. What exactly heat of hydrogenation means? When alkenes, no. When alkenes, we are doing the reduction. Friends of nickel, platinum or palladium, any catalyst, you get alkenes. So means double bond will becomes single bond, right? So here is heat is exothermic reaction. Exothermic reaction, heat is released. Whatever the heat is released, we are called as heat of hydrogenation, right? The heat of hydrogenation is depends on two conditions. So first one is heat of hydrogenation, right? We need to see number of double bonds directly proportional to number of pi bonds. Number of pi bonds, first we need to cross check. So if number of pi bonds are same, so then what we need to do? Heat of hydrogenation is inversely proportional to stability. So these 2 points are very important. Heat of hydrogenation is inversely proportional to stability. Now let me know the answer for this question. Exactly opposite. More stable, less heat of hydrogenation. Less stable, more heat of hydrogenation. Write it down. More heat of hydrogenation అంటే more negative ఉంటుంది, అంటే more exothermic, more heat అనేది రిలీజ్ అవుతుంది. Delta H negative exothermic reaction. Okay. Hmm. So first heat of hydrogenation is directly proportional to number of pi bonds. More number of pi bonds, right? More heat of hydrogenation is takes place. If the number of pi bonds are same in all the cases, that case is what we need to do? Need to cross check the stability. If it is more stable, less heat of hydrogenation. Done? Right. In these two cases, two only I am giving. So the following is the less heat of hydrogenation. Less heat of hydrogenation. Which of the following is less heat of hydrogenation? Less heat of hydrogenation means what? Compound is more stable. So how should we know? So here is only one alpha hydrogen, but in this case 9 alpha hydrogen. 3, 3, right? Less heat of hydrogenation means more. Write that statement. Don't confuse. Stable heat of hydrogenation. The two questions, because a lot of people are doing the silly mistakes in this particular case. Silly mistakes. Uh, Maximum lot of students what they are stability they are asking. They'll think like that, but they are asking the heat of hydrogen. Then next, one more important thing also we can discuss here: heat of combustion. Heat of combustion. So here is heat of combustion, Anna. First, I'll give the question, then we'll. So A, B, C. I'm giving the options. Which of the following more heat of combustion? Which of the following is more heat of combustion? More heat of combustion. Which of the following is more heat of combustion? How should we know? Combustion is different. What is combustion? When combustion means what? When whatever the organic compound, when we are doing the combustion, we'll get CO2 and H2O. This is exothermic reaction. Okay. For example, CH4 plus O2 gives rise to CO2 plus H2O, right? 2H2. So delta H is equals to what, Nana? Negative. This delta H, the whatever the heat is releasing, that we are called as heat of combustion, right? Anything if you are burning in terms of oxygen, not only alkene or carbohydrate, whatever it may be, right? So that is called as heat of combustion. If you take ethene, also for example O2, what will get CO2 and H2O, propane, anything, propene, any organic compound on combustion, what we will get? CO2 and H2O. Okay. Now, so how can we identify which is more heat of combustion, which is less heat of combustion? Same like that. So first, heat of combustion. Heat of combustion is directly proportional to heat of combustion is directly proportional to first what we need to cross check, number of carbon atoms, right? Number of First, we need to cross check the number of carbon atoms. If the number of carbon atoms are more heat of combustion. Okay. Then number of carbon atoms are same. That case is what we need to do. What we need to do? Point number one, first one. Point number two, heat of combustion is inversely proportional to stability. Write it down, these 2 points. Heat of combustion is directly proportional to number of carbon atoms. First, we need to cross check the number of carbon atoms. The number of carbon atoms are same. Okay. Now, more heat of combustion means what, Nana? Compound should be less stable. So, which is less stable? B. In this case, it is 3, 1, total 4. 4, right? In this case, only 2. In this case, 3, 3, 2, 8. So, B is less stable. B is less stable. Less stable means more heat of combustion. This more heat of combustion. Which one is less heat of combustion? This is less heat of combustion. Less heat of combustion. Then now we'll see some more questions. Here, the toluene, methyl benzene, is showing the hyperconjugation. Yes or no? Is it showing the hyperconjugation? Yes or no? Hello? Alpha, right? Double bond alpha. Showing, right, Nana? Write the structures. So double bond here, hydrogen, H plus, it is the negative charge. Okay. So then, come on, write it down fast. Now try to understand where the negative charge is coming. Where the negative charge is coming. Right? Ortho and para positions, electron density is increasing. So this we could say plus H group. Plus H. Plus H. So first is resonance or mesomeric effect is more powerful. So then afterwards hyperconjugation, then afterwards inductive effect. Inductive effect. Mesomeric effect, hyperconjugation, inductive effect. If three are coming at a time, so three are operating at a time, so what we need to give the priority? Mesomeric effect. So then hyperconjugation, then inductive effect. నేను ఏమని చెప్తాను జనరల్గా ఐ యూస్ టు సే దిస్ ఇస్ మెర్సిడీస్, రైట్, హోండా సిటీ, ఇండికా, రైట్, మెర్సిడీస్, హోండా సిటీ, ఇండికా. So three cars are in front of us. Which one we will choose? Mercedes, Honda City, Indica, right? Keep in this particular manner. And ortho and para positions, electron density is coming. So this is, we could say, ortho para directing group. Methyl group is ortho and para directing group. Ortho para directing group. Ortho para directing group. Ortho para directing group. Then today I'll give you some compounds. You need to identify this. You need to remember these things, right? For example, NO2 group is I'm giving. Tomorrow I'll ask this. And the NO2 is coming in front of us, so it is having minus M nature and minus I. Write it down. For example, OCH3. So this is what we can write, Nana, plus M and minus I. Plus M and minus I. CH3 plus H and plus I. For example, Cl, halogens generally. So plus M and minus I. But the thing is, this generally we won't consider the exceptional case. Hello. So whenever the chlorine is coming, so we need to say minus I. Exception. Exception. For example, OH group is coming. OH group is there. Plus M minus I. NH2 group is there. Plus M minus I. Okay. NH3 plus what, Anna? Minus M minus I. But first four are important. So first four, please remember and come. So we had n number of applications based on this. right? For example, NO2 is operating minus M and minus I. So if the minus M is working, so then minus I we generally have to neglect. Okay, na? Minus I need to neglect. OCH3 plus M minus I. CH3 plus H plus I, like that. Okay, clear everyone? And mesomeric effect also, plus M ortho is equals to plus M para plus M meta equals to 0. This is the same thing we can apply to what now? Minus M also. Minus M ortho is equals to minus M para minus M meta equals to 0. So means mesomeric effect is not operating at meta position. It's only operating at ortho and para positions. Ortho and para positions. Why? Hmm? Everything. So, for example, I'm just taking OH or OCH3. Anything is possible. Negative charge is coming at which positions? Double bond OCH3. This is ortho position first came. So when it is coming back, so means it's moving forward. So this negative charge, one more negative charge is forming it. Para. Once again, the negative charge is coming at which positions? Ortho and para and ortho. But it didn't affect anything in the meta position. Right? So that's the reason plus M ortho and para positions, the negative charge is equal. So mesomeric effect applying at ortho and para positions same, but it is not operating at meta position. The same mode minus M also, it is withdrawing the electrons from ortho and para only. So positive charge is coming at ortho and para positions, but not meta. Okay. So means OCH3, right? It operates which positions? Plus M, ortho and para. But meta positions, it's not operating. Got it? Hello? Dana? ఇప్పుడు డొనేటింగ్ గ్రూప్ కదా OCH3. హలో, ఇది ఆర్థో అండ్ పారా పొజిషన్స్లో మాత్రమే నెగిటివ్ ఛార్జ్ వస్తుంది. అర్థమవుతుందా? మెటా పొజిషన్ ఏం డిస్టర్బ్ చేయట్లా. మెటా పొజిషన్లో ఏ ఛార్జ్ రావట్లేదు అంటే OCH3 మెటాని డిస్టర్బ్ చేయట్లేదు. మెటా పొజిషన్ని ఆర్థో అండ్ పారా పొజిషన్స్ మాత్రమే ఎఫెక్ట్ చేస్తుంది. అంటే ఆర్థో అండ్ పారా పొజిషన్స్లో ఎలక్ట్రాన్ డెన్సిటీస్ ఇంక్రీజెస్. ఓకే. And if minus M is there, so the minus M, for example, any example we can take like NO2 group, right? It is taking the electrons from, hello, which positions, Rana? This is the positive charges come. Next step, Hmm? Positive charge is coming at para position. Once again. కన్ఫ్యూజ్ అవుతున్నారు ఎవరైనా? హలో, ఎనీబడి కన్ఫ్యూజింగ్? Now it is withdrawing, right? So it's taking the electrons from ortho and para positions only. So we got the positive charge where nana? Ortho position, para, ortho. So means it is taking the electrons from ortho and para positions. It is not affecting the meta position. So both statements, which statements? So plus m ortho, a lot of students are confusing in this particular case, nana. Okay. And plus m nature means what? Donating nature. Minus m nature means what? With taking. So plus m groups generally we are called as ring activating groups. Ring activating, right? Minus m deactivating groups. Minus m deactivating groups, right? Hello. Dana? So they'll ask one sample question I'll discuss today. Right. Write the question. Which of the following carbocation is more stable? 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 I told you OCH3 is which nature? Plus m. Plus m is working here, right? Plus m. If the plus m is working, we no need to take the minus m, right? What about this one? CH3 plus H, right? What about this NO2 minus m? What about the chlorine? Chlorine minus I. So the stability order, nana. So CH2 plus is electron deficient compound, right? It needs electrons. And someone has to donate the electron. Someone has to donate the electrons. So it's looking for the electrons. So means donating groups are more favorable. Which are more favorable means following order. So plus M first, then plus H, write it down, then plus I, then neutral molecule. So then, so minus I, minus H, then minus M. So you need to follow whenever the donating groups are needed. So this order we need to follow. Come on, write it down. So first plus M is there, plus M. answer A first, then plus H, B, right? Then plus I, there is no plus I, no need. So then neutral molecule, there is no neutral molecule. Then minus I, D, there is no minus I, so only minus M is there. So AB, DC is the answer. Right? Anybody confusing, please let me know. I'll explain once again. Hello. Anybody confusing, please let me know. Hi, అర్థమవుతుందా? Hi. ముకుంద్, వింటున్నావు? వింటుపోయినాక చూసుకో, యూట్యూబ్లో వస్తాను, కెమెరాలో పడ్డాను. అట్లా హాయ్ ఫ్రెండ్స్. రా. The remaining I'll continue from here onwards. I'll continue tomorrow. Okay. So revise and come back, everyone. Right. So the groups plus M, minus M. So this is very important. So what we did today. So I just revise once. Right. System starting from here. So I'm just keep on revising. This is the first one. So which of the following is more acidic nature? So because this is the third one, because after losing the H plus, this compound becomes aromatic, right? Next. So this is also very important question which I discussed. So CC, right? CC bond length is where the, in which case which is more means obviously in the first case, because both are aromatic nature. And CC free rotation in these two cases where it is possible means first one, because generally CC single bonds cases free rotation is possible but not double bond, right? Right, Ron. So the stability of carbocations we discussed. More number of alpha hydrogens compound is more stable. So here also number of alpha hydrogens here is 8, in this case 4. 8 is more stable than this one. Here is also 6 and 7. 7 is more stable. The same thing, hyperconjugation we explained in alkenes also. In alkenes, more alpha hydrogens compound is more stable. And I told you heat of hydrogenation. Heat of hydrogenation is directly proportional to number of carbons. Number of pi bonds. More number of pi bonds, more heat of hydrogenation. And if the number of hydrogen means number of pi bonds are same, that case is we need to see the stability. The same low heat of hydrogenation. Low heat of hydrogenation means compound should have more stable. So which is more stable? B. Right? B. This is the answer is B. So then heat of combustion also we discussed. Heat of combustion. So heat of combustion is directly proportional to number of carbon atoms. More number of carbon atoms, compound is more heat of hydrogenation. And heat of, if the number of carbons are same, so then we need to go, right, cross check with the stability of compound. Then the last case we discussed a number of things. Here is, I told you these things while coming tomorrow. Just you need to remember all these, at least 4, above 4. Okay. Hello. Okay, na? At least above 4. So based on we had lot of applications. Here onwards exactly GOC will start, right? So purely easy topic, try to understand. If you are not following, please let me know. Everything is easy, everything is easy here. Okay, don't confuse. We'll go by step by step, step by step. So where we are generally doing the mistakes and everything, I'll explain. So plus m ortho and plus m para, right? I told you because plus m group is operates at ortho and para positions only, right? Minus m also operates at ortho and para positions. It's not disturbing the meta position. Got it? For example, OCH3 group is there, it is giving the electron densities increases at the ortho and para positions, but it's not disturbing the meta position. So why this means, this is based on this, we can explain. Minus m also. In case of minus m, it's taking the electrons from ortho and para positions, but not meta position. Got it? So these things are very important, and try to understand, learn this order also. First mesomeric effect, then hyperconjugation, then inductive effect. For example, donating nature, which is more donating means obviously plus m, plus h, plus I. The neutral molecule, and withdrawing nature, minus I inductive effect is somewhat very less, then minus h and minus I. For example, some groups or withdrawing groups are more favorable, like acidic nature, right? That cases what we need to do, opposite the order. What the order for withdrawing groups? For example, CH2 minus and that cases, first we'll go with the minus m, minus h, minus I. More withdrawing nature, somewhat less and very less. So then neutral molecule, plus I, plus H, plus N. This is for which one? No, withdrawing nature, like carbene ion and acidic nature. Carbene ion cases and acidic nature cases. Acidic nature of carboxylic acids cases, we need to follow this order. So this is for carbocation, right? And basic nature of amines. Basic nature of amines, we will follow this order. Okay. So remaining year onwards, I'll discuss tomorrow. These two orders we need to know, and we need to identify which group is which one. How should I told you. So remember and come back. We had n number of applications, we will do tomorrow. Hello guys, we'll continue from tomorrow onwards. We'll start the ionic equilibrium. ఏమైందిరా లైటింగ్ ఎక్కువైంది. రైట్ హలో రైట్ నాన్న. Last class what we were discussing, buffer solutions, right. Buffer solutions are basically two types: acidic buffers, basic buffers, right. Acidic buffers means what? Buffer means whenever we are adding the small amount of acid or base, there is no change in the pH. Those were called as buffer solutions. Example is our blood is a buffer, right. Buffer, then pH is 7.4. Acidic buffer means what? Weak acid and its salt of strong base. For example, CH3COOH plus CH3COONA. The mixture we are called as acidic buffer. So what is the pH for the calculation? pH, acidic buffers, pH is equals to pKa plus log salt concentration by acid concentration. What is this? Acidic buffers. Acidic buffer. What about basic buffers, Nana? Basic, weak base and its salt of strong acid. Right. For example, weak base, I'm just taking NH4OH plus NH4Cl. Right. POH. How can we do? POH is equals to pKb plus log salt concentration by what, Nana? Base concentration. So we know pH plus POH is equals to 14 based on that. So we need to calculate the things. Next, today we'll discuss, right, solubility product. Put that in. Solubility product. Solubility product. For example, AB is a compound solid. When it is dissolving in water, so it becomes A plus plus B minus. This is solid. This is aqueous. Sparingly soluble salts. So sparingly soluble salts are in the equilibrium with the ions. Sparingly soluble salts means what? Some salts 100% dissociation won't take place. Right? This solubility we can say the S. Right? Generally, what is the equilibrium constant, Nana? Equilibrium constant K is equals to concentration of A plus the concentration of B minus by AB concentration. The solids concentration is unity, right? So this is also constant. right? So simply what we will take, so this constant and K, we'll write KSP, solubility product. KSP is equals to concentration of A and concentration of B. Tell me, Nana. Solubility product. So ఎందుకు రావట్లేదు ఆఫ్లైన్? ఆఫ్లైన్ ఎందుకు రావట్లేదు? పెడుతుందా? బెటర్ వేసుకొని రావాలి. S into S, no? Solubility. KSP is equals to S into S. That means we had different types of salts now. This is AB type, right? KSP is equals to S into S, we can write S square. What is KSP means? Solubility product. S means solubility. So S is equals to what? What we can write? S is equals to the root of KSP. AB type cases we will use this. AgCl, AgBr, AgI comes under this category. AgCl, AgBr, AgI. Okay. AB2 type. Shall we do the AB2 type? Completed. For example, AB2 type. What, Nana? How it is dissociates? This all. A plus 2B minus. A plus 2B minus. This is solubility S. This is 2S. What is KSP? KSP is equals to, right, concentration of A plus and concentration of B minus whole square. Here is S. KSP is equals to S into 2S whole square. KSP is equals to S into 4S square, right? So KSP is equals to what now? KSP is equals to 4S cube. What is S right here? S is equals to under root of KSP by 4 cube root. Then Pranay Rasava. AB3 type. AB3 type. What? A plus 3B minus. Three plus రాయొచ్చు కదా, AB 3 plus. Then only this crisscross method. This is solubility S, this is 3S. Directly I am writing KSP is equals to S into 3S power, so S into 27 s power 3. Nothing but 27 s power 4. So ksp is equal, s is equals to what? Root ksp by 27 fourth root, right? Last A to B3 type. A to B3. What one? 2A 3 plus 3B 2 minus. So solubility 2S 3S. Ksp is equals to what? 2S whole square 3S whole cube. So 4s square into 27 s cube. 27 into 4 how much? 108 into s power 5. S is equals to under root ksp by 108 fifth root. కనిపిస్తుందా బోర్డు అందరికి? హలో, write a question. Write a question. The solubility product, sorry, the solubility of silver chloride AgCl in water at 25 degrees centigrade, in water at 25 degrees centigrade, in water at 25 degrees centigrade is 1.06 to 10 to the power of minus 5. 1.06 into 10 to the power of minus 5 mole per liter. Mole per liter. Calculate the solubility product of AgCl. Calculate the solubility product of AgCl at this temperature. At this temperature. Come on, try it. Direct question. One point one two into 10 to the power of